Hi guys, welcome to the third video in our tutorial on Microsoft Orleans and building a distributed banking application using the Orleans Actor framework. In this video, we're going to start the implementation of our first grain, silo, and client in Visual Studio and C#. We're going to show you exactly how to set it up and configure it to use the Azurite storage emulator to back some of the Orleans services. Hopefully we'll be able to use some of the theory we saw in earlier videos and put them into actual use in this one. If you're not interested in C# or you're not using Visual Studio or you don't want to follow the implementation, you can skip this video if you want. There'll be a couple more videos with some more theory in the future. So let's leave it there. Let's get into the actual implementation and let's start creating the banking application with .NET and Microsoft Orleans. Don't forget to subscribe and hit the notification bell if you want to keep up to date on these latest videos. So to kick us off, we just have opened Visual Studio here. Before we do that, we just want to make sure that we have the Azurite storage emulator installed and working on our machine. So this is something that Orleans will rely on for a lot of the functionality that Orleans provides us. So we won't be interacting with the storage emulator directly, rather the Orleans runtime will be using it. And Orleans does offer in-memory and local host versions of this, but in my opinion, it's better to start off closer to what we want to be using in production. So that's why I've opted to use the Azurite storage emulator from the start. So to install it, we just type npm install g Azurite, assuming that you have npm installed on your computer. I'm not going to run this because I already have Azurite installed. But then to run it, we can typically type Azurite, and that should start our emulator, as we can see there. So that's essentially all we have to do to run the emulator, and we just want to make sure we do that every time we start our computer, or we can set it up to start automatically. I think some later versions of Visual Studio actually have the Azurite storage emulator built in, so that might be already running, but for me the most reliable way is just to start it via the command line. Now what we want to do is we want to start and create a new solution and project in Visual Studio, and to kick us off I'm going to start off with the ASP.NET Core empty project template. And this is essentially going to be the HTTP web API that's going to run the Orleans client, and then it's going to make calls to our Orleans silo. So let's click that. Let's click next. And then we want to give it a name. I'm simply going to call it Jumpstart CS Orleans client. And we can create that. And I'm going to change the solution name just to be Jumpstart CS Orleans. So that's the configuration we have. Orleans client is the project, the solution name is Orleans, and that's because we're going to add other projects under this solution to host both our silo and our grains. We're going to use .NET 8 here, so let's create that. So once that's created, we can see we've got a very bare bones client here. And the very first thing we're going to do is we're just going to add two new projects under this solution. The first one is going to be a class library that's going to have our grain code in it. And the second one is going to be a console app that is going to be our silo. So let's right click, add new project, console app first. Again, we're going to use the name Jumpstart CS Orleans. And we're going to call this one silo. Again, the same configuration as before, the same framework. And we want to add a class library for our grains. So new project, I want to select class library. Again, we're going to use a similar naming convention. So Jumpstart CS Orleans. We're just going to call this one grains. And the reason we've had a separate project for grains is just to abstract those grains away and keep our code nice and separate from each other. Okay, so first we're going to set up our Orleans client. So at the moment, all we have here is essentially a bare bones API with one API, HTTP API endpoint that's been added by default by the template. So we're going to set up this web client to essentially use an Orleans client, which will then eventually be able to make calls to our grains. So the first thing we want to do is install some NuGet packages. So we can right click on the project and then click manage NuGet packages. And we want to browse and we want to search for a couple of different packages. So the first one we want to install is the Orleans client. So we can just search for that. And we can see this one here, Microsoft Orleans client. So let's install that. So once that's installed, we also want to install Microsoft Orleans clustering Azure storage. So this is the one that requires us to have Azurite running. So we have it here, Microsoft Orleans clustering Azure storage. So let's add that as well. And the clustering essentially is the thing that tells Orleans the IP addresses, where our silos live, where everything lives. So that's kind of how it all hooks up. So let's jump back into our program and set this up so it can use Orleans client. So we want to hook Orleans into our builder. So we'll do builder.host use Orleans client. Set it up here. So context client. And in here is where essentially we configure our client. And the first thing we want to do is just configure the clustering to use Azure storage. So we do use Azure storage clustering, configuration options. And this is where we essentially need to point it at the table that we wanted to use on our emulator. Table service clients, new Azure data tables, table service client, and we'll pass our connection string in here. Because we are just using the storage emulator, what we essentially want to write is use development storage equals true. And if we wanted to use this in production, we'd essentially just have to change this connection string here to point at a real Azure storage account. And the final thing we need to do inside this use Orleans client is essentially configure the cluster ID and service ID. So we can do that with client configure, cluster options, and here we essentially just set the cluster ID, and we'll just call it jumpstart CS cluster, and we want to set the service ID as well. So jumpstart CS service. So the cluster ID obviously just uniquely identifies our cluster, and the service ID uniquely identifies our service. So we could have, I think, multiple services running in the same cluster, but in every application I've seen, we've essentially just had a cluster and one service ID. But this is where if you wanted to do something a bit different, you would configure it here. And that's essentially everything we want to do here for now. We will come back in a few minutes after we add our grains and our silo and add a HTTP API call here just to proxy to our silo. Okay, so next let's add the grain code in the grains project. So remember, this is just a class library, so this is where we're going to add our grains and some other things like that that could be shared across silos. So we're just going to add a folder that will store our grains, and we'll add another folder that will store our abstractions, so our interfaces mostly that will be used to interact with these grains. And then we just want to add, again, a few NuGet packages to make sure we have everything we need to write the code for our grains. So again, right click on the project and go to manage NuGet packages. We want to add a few different ones here, but some also the same. So we can just search for Orleans. And what we want to add is we want to add Microsoft Orleans core abstractions. We want to add Microsoft Orleans runtime and Microsoft Orleans SDK as well. So let's search for them. Runtime and SDK. I actually think we added the wrong runtime there, so let's just re-add runtime, and we want to add this one here, the 8.1.01 at the moment. So install, because we're using the latest version of Orleans in this tutorial as of the time of creation. So now that we've added those packages, we want to start adding the files we're actually going to use for our Orleans system. So we're going to add the checking account grain first. So this is the grain that will take care of all of our account details, account balances, and different things like that. And every grain interacts with the outside world and other grains through an interface that represents the methods that are available in that grain. So we'll have to add both an iChecking account interface in the abstractions folder and also a checking account grain with the actual implementation details in the grains folder. So let's start with the abstraction here. So we'll go add a new item and we're going to call it iChecking account grain. And it's an interface. We'll make it public. And with all of our grain interfaces, we need to also implement iGrain with some sort of key which represents what type of identity this grain has. So in our case, we're just going to use a GUID for this, but you could also use an integer key, a string key, or we're going to use iGrain with GUID key. And then we just want to add the methods that we want our checking account grain to support. So for this case, we're just going to have a simple initialize method, which just takes an opening balance. Easy peasy. And we're also going to have a get balance method, which will return this balance. So it's going to return a decimal. It's going to be called get balance. And it's not going to take any parameters. And note how these methods don't actually take any ID of a grain or ID of the checking count we want. And that's because we call these methods when we already have the reference to the grain that we want to use. So we use the ID when we're getting the reference to the grain. And then when we call these methods, we already are on that grain, so we don't need to pass the ID. And we'll get into that in a bit more detail in a future video where we talk about grain communication. So let's just delete these unused usings, and we'll go ahead and actually create the checking account grain itself. So we'll go add new item, and we'll call it checking account grain. So this again is obviously a class. And that will implement the interface we just created. So iChecking account grain, and let's go ahead and add the methods for that. The grain also needs to inherit from the abstract base class that Orleans provides us called grain. So we'll just do that now. And that's essentially the core setup for this grain. So we just need to go ahead and actually implement these two methods here. Again, in a future video, we'll talk about persistent storage on a grain, but for now, we're just going to add a field on the grain to store our balance. And this obviously will be completely vulnerable to being erased if the grain goes deactivated or if the silo dies and different things like that. But we will remedy that in a future video when we add persistence. So private decimal, and we'll just call it balance. And the get balance will obviously just return the balance. I'll make that method async. Make this method async as well, and the initialize will just set the balance for now. And we'll just get rid of the unused usings as well. And I'll just delete this empty class. That is essentially everything we need to do in the grains project for now. Obviously, we'll be adding new grains, new abstractions in the future, but for the very simple starting point, that's what we need to do. So next, let's jump over and actually set up our silo that will host these checking account grains. Okay, so let's close these and let's jump into our silo project. So this is what will host our actual grains. And as usual, first thing we want to do is add some NuGet packages. So we want to browse nuget.org, and essentially what we're looking for is very similar packages to what we add in the client, except we'll be adding the server package. So again, we want Orleans clustering with Azure storage to know where our different silos and grains live. We also want the Orleans runtime. Again, we're looking for this one, not Orleans.Orleans runtime. We're looking for Orleans.runtime install. And then finally, we want Orleans server. So in this case, we're installing the server rather than the client. Here we go. So with those three packages, we should be able to jump into our program and we should be able to start adding what we need to instantiate and run our Orleans silo. So the first thing we want to do is just add a usings from Microsoft extensions.hosting. And then we should be able to do await host.create default builder. And inside this builder, we have the command line args. And then we just want to do .use Orleans. So we're using use Orleans here, not use Orleans client, because this is a silo and not a client. Silo builder. And again, in here is where we will actually configure all of our settings for our silo. So we'll actually copy over some of them from the Orleans client because they can be the same. So we're using the same Azure storage clustering table and connection string, and we're using the same cluster options for cluster ID and service ID. So just to make sure we don't have any errors retyping out these names, we'll just go here and copy them in directly. Obviously these need to change to silo builder, but they should have the same methods. If we just skip down the bottom, we want to just do .run console async to run this as a console app, and that should get rid of all of those squiggly red lines that tell us there's an error. And that's essentially it. That's all we really need for now in this method. This is where we'll add things like configuring our reminders, transactions, streaming in the future, but for now we can keep it relatively bare bones. One thing that might be worth mentioning is that this is also where we can configure kind of our grain lifecycle. So if we go to silo builder, configure, and this time we go for grain collection quantum, or grain collection options rather. Inside there is where we can kind of tell Orleans how often we want our grains to be cleaned up. So how often we want them to be deactivated. So when we call a grain, it generally gets activated, and then when it returns, it's still active, but then after a certain period of time, it gets cleaned up and deactivated, waiting for another thing to call it again to free up resources in our system. So we can actually change how long a grain needs to be not called for it to be eligible to be cleaned up. And we can also change the period of time between cleanups. So we can do that with options.collection quantum. So I believe this is how regularly we actually run a collection job, kind of similar to garbage collection, where we say, oh, these grains haven't been called in X amount of time. I actually want to deactivate them now. So we do time span from seconds. One would obviously be very low, but we might say if we want a very regularly correct collection, we might say 20 seconds. And then we might have options collection age, which really just says, oh, after a grain has not been kind of used for 20 seconds, we want them to be eligible to be cleaned up. And then the next time the collection quantum ticks over, that's when they'll be collected. We don't really need to set any of these values for our cluster, so we'll just comment them out for now. Okay, so now that we've got our silo set up, let's jump back to our client and actually add some HTTP API calls that will use the Orleans client and make calls to our silo to get the balance and set the balance on our checking account grain. So we do that in our program CS here. We're just going to use the lightweight app.mapGet and app.mapPost to do these endpoints. So to create a checking account or to initialize it, we just want to do checking account. And we want to pass a couple of different parameters here into our method. So what we actually want to get and what we want to use here is the iCluster client. So this is the Orleans client that we have access to. And we want to call a method on this. So we want to do cluster client and we want to call get grain. So this will get the reference to the grain we're using, and we need to use the grain interface here. So we need to right click on our client and we need to add a reference to the grains project we have. So we go file, add, and then project reference, and we want to add one to grains. So that should give us access to the iChecking account grain now. And we need to pass an ID for this grain. So for this, we'll just create the ID because like we saw in a previous video with the virtual actors or virtual grains, if the grain doesn't exist already, when we call a method on it, the Orleans runtime will just create the grain for us with that ID. So we'll go var checking account ID. And we'll do good.newGood to get a new good. And we will pass that into the getGrain method as the ID of the grain we want to get. And we'll say var checking account grain. And interesting to note is that this method isn't async. So we're not actually making any network call here. We're just using the library to get a reference to the grain. We don't actually check if that grain exists or it's valid or anything like that until we actually call a method on the grain, and then that passes a message to that grain to do some work. And doing that is pretty easy. So we just get the checking account grain, and we can see we have access to the methods get balance and initialize. So we'll just call initialize, and we want to pass an opening balance. And we'll get the opening balance from something we will pass into the API. So basically from some JSON payload that we'll pass here. So to do that, let's actually add a new folder here, and we'll call it contracts. And then we'll add a new class in here called create account. So this will have everything we want to create account. We'll make this a record for now. And we'll make it a data contract just to make sure it's serializable, and this can serialize from, or rather deserialize from JSON into this kind of object, data member, and we just want to have the opening balance really. So public decimal opening balance get, and we'll make it init only. So this means that this object can now, if we go back to our program, we can now pass this create account object as part of the body of this post, and this create account has the opening balance on it. So that way we can call the initialize method and pass an opening balance through our HTTP API to the checking account grain in question. And note, we want to await this because this is making the network call to the grain. This will create a message that's sent to that grain, and we'll wait until that message is processed by the grain. And finally, we can just return. So type results, and we want to probably say created, and we can just pass the reference location. So checking account and the checking account ID we created, and that should be okay for now. So that's essentially our post method for creating the grain. Let's just add the one for getting the balance. So here we want to pass the checking account ID in the root as a root parameter, and we want to do a get. So we're just going to do /balance. Again, we actually want to use the cluster client here again. So we'll get that and pass it in, and this is passed through dependency injection using ASP.NET Core Magic. And inside our method, we want to get a reference to that checking account grain. But in this case, rather than using the brand new GUI that we've just created, we're actually using the checking account ID from the root parameter. And to use this root parameter, we also want to pass it as into this method. So we can do GUI checking account ID, and that will give us access to the check account ID here. And now obviously we want to make the get balance call, so we'll just call var balance equals await checking account grain dot get balance. Easy. That will return our balance, and then we can just return that over the API. So return type results, okay, and the balance. And that's essentially our two API calls that we're going to use. So I think at this stage now we have everything we need to run our client and run our silo, and then we can make these two API calls and we can see if everything works as expected. We might have missed one or two small things here and there, so let's run and see if we missed anything, and we can go back and tidy it up afterwards for any mistakes we've made. Okay, so we want to start both the client and the silo at the same time, because remember, we're not running our Orleans silo in the same process as our ASP.NET API. You can do that, but for the purpose of this video, we decided not to. So if I right click on my solution, and if I go to configure starter projects, I can change it from a single starter project to multiple starter projects. And I want to start the client and the silo, so we just change both of these to start. We click apply, we save our changes, we click OK. Remember, grains is just a class library, so there's actually nothing to start there, so we can leave that as action none. And we click start, and hopefully our cluster will just start itself. We can see here in this window that we seem to have started relatively successfully. A couple of failures. Hopefully nothing to worry about. It looks like it was transient just on startup. So let's make some API calls for our checking account and our checking account balance using Postman. And let's see, do we get what we expect? So I have Postman window open here. I'll make it bigger. Hopefully people can see that. The text is a little bit small. But essentially what we're doing is we're just going to call initialize checking. Just make sure you have the port number correct. And we pass our checking account and we pass an opening balance of €1,000. We'll send this and we can see we get an exception, could not find implementation for interface, Jumpstart Orleans grains abstractions, checking account grain. And the reason why that happened, if we actually jump back to Visual Studio on Orleans, is because the grain silo doesn't actually have any reference to any of the grains it's hosting. To add the reference to the grains, we just simply have to add a project dependency from the silo to the grains, and that will tell this silo, hey, I want you to host a checking account grain. So for instance, if we had one silo that we wanted to host checking account grains and another silo that we wanted to host just ATM grains, but not checking account grains, then we'd have to have two separate grain projects, and each silo would just reference the project that has the grains that that silo wants to host. In our case, we want this silo to host everything, and everything in this case is just our checking account grain for now. So if we right click on our silo and we go to add project reference, and we want to reference our grains. So we click OK, and then we can restart our client and our silo. You don't have to right click and go to set starter projects again. That should be saved in Visual Studio. So we will start. Our silo will come up. And we now should be able to make these calls. So let's open Postman. Let's hope that we don't have forgotten anything else. Click send. And we see we get here a 201 created. And if we see in the headers, we can actually see the location of this checking account grain that was created. So let's grab that GUID and let's go into get checking balance. Let's copy in the GUID of the one we want to check, and we should expect to see 1,000 on this one. The port number, I believe, needs to change in my Postman. So we're making a host to localhost / checking account. The ID that was returned from the call to initialize / balance. And we can see that we get 1,000. An interesting thing would be to just change the GUID slightly and ask for the balance. And we should see that we get 0. We don't get a failure. And that's because the grain actually gets created on any call. So the initialize does not have to be called for the grain to be created. The grain can be created on any call to that grain and be activated. Thanks for watching this video, guys, where we just set up a basic grain client silo and we made some calls over HTTP API that then proxied to our grains. In the next video, we're going to look at grain persistence. So we're going to take our checking account and we're going to add persistence to that. So the balance that we saw there doesn't disappear when our grain resets or our grains get collected and deactivated. In future videos, we're then going to look at grain communication and other things like timers, reminders, and streaming. If you like this video and you want to keep learning more about Microsoft Orleans, don't forget to subscribe to the channel and click the notification bell to get updated for new videos on both this topic and other topics in distributed computing and distributed application development.